Imagine turning up the heat on an entire planet. The air warms, the oceans absorb the energy, ice begins to disappear. Sea levels rise, extreme weather changes. This is not one problem. It's a chain reaction, and it has already begun. But how does a change we can barely feel in our daily lives transform an entire planet? The answer begins with something invisible: greenhouse gases. For thousands of years, Earth's climate remained within a relatively stable range. Then, humans began burning coal, oil, and gas on an enormous scale. Carbon dioxide and other greenhouse gases accumulated in the atmosphere, trapping more heat within Earth's climate system. The result is unmistakable. Human activity has caused global warming, and Earth's average surface temperature has risen significantly compared with the pre-industrial era. But here's where the story becomes surprising. The extra heat doesn't simply remain in the air. The ocean absorbs the vast majority of the excess energy accumulating in Earth's climate system. Think about that. While we experience warming through the atmosphere, an enormous amount of the planet's extra heat is disappearing into the ocean. And this matters because the ocean isn't just a giant reservoir of water. It is one of the planet's greatest climate regulators. Now travel north, across the Arctic, Greenland, and mountain ranges around the world. Another signal is becoming impossible to ignore. Ice is being lost. Glaciers are retreating, and the Greenland and Antarctic ice sheets are losing mass. But not all melting ice affects sea level in the same way. Floating sea ice already displaces water. Land ice is different. When ice stored on land melts and flows into the ocean, it adds new water to the sea. And there's another mechanism. As seawater warms, it expands. So the ocean rises through both melting land ice and the expansion of warming seawater. The result is global sea level rise. And the rate of that rise has increased over the modern observational record. For coastal communities, this isn't an abstract number. Higher seas can make high tides, storm surges, and coastal flooding more dangerous. But the chain reaction doesn't stop at the shoreline. A warmer climate can also change the behavior of extreme weather. Heat waves become more intense and more frequent in many regions. Heavy precipitation events can also become more intense as the atmosphere holds more moisture. That doesn't mean every storm or heat wave is caused entirely by climate change. Weather is complicated, but scientists can identify how a warming climate changes the odds and intensity of many types of extreme events. And suddenly, the separate pieces begin to connect. A warmer atmosphere, a hotter ocean, less ice, rising seas, changing extremes. None of these changes exist completely on its own. They are parts of one interconnected climate system. And that is what makes global warming so difficult to understand. The number on a thermometer is only the beginning of the story, because Earth's climate is not a collection of separate machines. It is one enormous system. Change one part, and the effects can travel through the others. Greenhouse gases warm the atmosphere. That warming transfers energy into the ocean, contributes to ice loss, raises sea levels, and changes the conditions under which extreme weather develops. So where does this story end? The uncomfortable answer is, we don't know exactly, because the future is not completely predetermined. The amount of future warming depends strongly on what happens to greenhouse gas emissions. The planet is changing. The evidence is already around us, but the final chapter hasn't been written yet. And that may be the most important fact of all.